Today is the most important day of your calculus careers. Today is the day where I prove to you the fundamental theorem of calculus. Now this theorem relates the antiderivative or the indefinite integral with the definite integral. So here I have two graphs. The one on the bottom is f of x and the one on the top is g of x. G of x is actually the antiderivative of our function f of x with respect to x. So what we're actually going to do is use the Riemann sum using three rectangles to approximate the definite integral of f of x. So we can actually write this as change in x, delta x, multiplied by each of our C1, C2, and C3. And here are the widths of each of our three rectangles. However, we still need to find our C1, C2, and C3 values. Now we're going to be strategic and choose these C values carefully. Well, we just learned the mean value theorem, so why not we use that? We're going to define our C1 value as the point that satisfies the mean value theorem for each of these intervals. So the derivative of g at point C1 is actually going to equal g of x1 minus g of a divided by delta x. In other words, the instantaneous rate of change at point C1 is going to equal the average rate of change from x1 to a. Since our g of x is actually defined as the antiderivative of our f of x, we know that the derivative of our g of x is going to equal f of x. Thus, this value is actually equal to f of C1. Similarly, let me just catch up our graph. Our C2 value is going to equal g of x2 minus g of x1 divided by delta x, which is going to equal f of C2. And g of C3 is equal to g of b minus g of x2 divided by delta x, which is going to equal our f of C3. So if we substitute these values into our Riemann sum, we are going to get delta x of g of x1 minus g of a plus g of x2 minus g of x1 plus g of b minus g of x2 all over delta x and if we cancel these out, we are left with g of b minus g of a, which is equal to the definite integral of f of x with respect to x from a to b. Because as you notice, no matter how many rectangles we split this up into, everything's going to cancel out except for our two endpoints.